By the end of this video, you'll know how to create a Trammel of Archimedes in Fusion 360. The Trammel of Archimedes is a mechanism that generates the shape of an ellipse. Some have even coined the machines to be the do-nothing machines, as they're pretty pointless when they have a knob on the end. Now usually they have a pencil or knife attached to the end, so one can draw or cut an ellipse into a surface underneath. These are great little projects for woodworking or 3D printing, and the kids seem to love them, so I thought this would be a fun object to model in Fusion 360. Before we get started, be sure to check out productdesignonline.com/7. That's productdesignonline.com/7. And that URL will automatically redirect to a page with some additional resources. First, I'm just going to click the save icon in the toolbar, and I'll name this Trammel of Archimedes. Then I'll hit the blue save button. Then, to get started with the model, we'll want to create a new component for the base, or the large part with the slots in it. I'll select the Assemble drop-down list, then I'll select the New Component option. I'm going to type out track for the component name, and then I'll select the OK button. With the base component now active, I'm going to activate the rectangle command using the keyboard shortcut letter R as in Romeo. Then, you'll be prompted to select the plane to sketch on. I'm going to select the XZ origin plane. Before sketching anything out, I'm going to select the center rectangle option in the sketch palette. I'm simply selecting the center rectangle option so I can center this rectangle with the center origin point. Therefore, I'll click on the center origin point and I'll drag out with my mouse. I'll type out 20 millimeters for the width, followed by the tab key to lock the dimension in place. Next, I'll type out 140 millimeters for the height, also followed by the tab key to lock the dimension in place. Then, I'll simply click to set the rectangle in place. At this point, we need a rectangle of the same size running in the horizontal orientation. Instead of creating another rectangle from scratch, I'm going to use the circular pattern tool, as this will limit the number of dimensions I use in this sketch. I'll select the sketch drop-down list, then I'll select the circular pattern option near the bottom of the list. I'm going to click and drag with my mouse cursor to select the entire rectangle, including the reference geometry in the middle. However, before we can select a center point for the circular pattern tool, we'll need to deselect the center point of this rectangle, as it can't be used for both the object selection and the center point selection. I'll simply click on the center point of the rectangle. Then I'll have to select the center point selector in the dialog box. I can now reselect the center point of the rectangle. You'll now see we have a quantity option in the dialog box. I'll change the quantity to 2 instances. Next, I'm going to set the type option to angle so I can set the angle to 90 degrees. Finally, I'll click the OK button to confirm the results. We'll now want to extrude this sketch to turn it into a 3-dimensional object, which we'll then use to create the track of the machine. This sketch has 5 different closed profiles, as you'll see as I hover my mouse over each area of the sketch. Instead of selecting each profile one by one, I'm going to select the entire sketch again. Then, I'll hit the keyboard shortcut letter E as in echo to activate the extrude command. For the height, I'll type out 19 millimeters. At this point, we need to cut the slots out of the track. I'm going to hit the keyboard shortcut letter L as in Lima to activate the line command. Then, I'm going to select the face at the end of one of the rectangles as we'll draw a profile shape and then we'll extrude cut it away from this component. I'm going to turn on the construction option by selecting it in the sketch palette, as we'll first need to create a reference line. I'm going to click on the bottom origin point, then I'll create a line going upwards. I'll type out 3 millimeters, then I'll click to set the line in place. Before I draw the rest of the lines, I'll select the construction function in the sketch palette to turn it off. I'll make a horizontal line going to the left with a length of 7 millimeters. I'll click to place the line, then I'll draw a line towards the top, typing out 12 millimeters for the length. I'll hit the tab key to lock the dimension in place, then I'll set the angle or degree input field to 75 degrees before clicking to place the line. For the next line, I'll create a line that goes all the way to the top edge, making sure that this line is vertical or at 165 degrees. I'll click to place the line, then I'm going to draw a line to the right where it snaps in at the y-axis. Now that we have half of the profile sketched out, we can mirror the sketch to the other side to create the other half. I'll select the sketch drop-down list, and then I'll select the mirror command. It's important to note that the sketch mirror command only works with sketch geometry, and you need to select that one and not the modeling mirror command that is located under the create drop-down list. Once the mirror command is active, I'll select the 4 lines that make up the sketch so far. Then I'll select the mirror line selector in the dialog box. For the mirror line, I'll select the dashed reference line at the bottom. Then I'll click the OK button to confirm the mirror results. At this point, we'll use the profile to extrude the track. I'll select the extrude command in the toolbar, and then I'll select the profile. I'll change the operation type to cut, as we want to cut the shape away from the existing body. Then I'll change the extent type to all to ensure the cut goes all the way through the body. Finally, I'll click the OK button to confirm the results. Now that we have one of the tracks cut out, we can pattern the second track cut out. This time, I'll select the Create drop-down menu, and I'll find the Pattern Flyout folder. And I'll select the Circular Pattern feature. First, we need to change the pattern type to the Features option. This will allow us to select the Extrude feature in the Fusion 360 timeline. Next, we'll need to select the axis. I'll select the axis selector, and then I'll select the y-axis. I'll then change the type selection from the full option to the angle option. I'll type out 90 degrees, then I'll change the quantity selection to 2 instances before selecting the OK button. Let's now add some fillets to finish off the track. I'm going to hold down the Shift key on my keyboard, and then I'll select all 8 of the outside lines. Then I'll hit the keyboard shortcut letter F as in Foxtrot to activate the Model Fillet command. I'll type out 3 millimeters for the fillet radius, and then I'll click the OK button to confirm the results. We'll now need to create a new component where we'll create the bodies that slide in the track. I'll right-click on the top-level component in the Fusion 360 browser. Then I'll select the New Component option. To rename this component, I'll click once to select it, and then I'll click again to open up the input field. I'll type out slider for the name, followed by hitting the Enter key on my keyboard. With the slider component active, we'll begin by offsetting a sketch on the edge of the track. I'll select the end face of one of the tracks, and then I'll hit the keyboard shortcut letter O as in Oscar to activate the offset command. Then we'll have to select the face once again which selects the outer sketch geometry of this face. I'll type out 0.5 millimeters for the offset dimension, which will act as our 3D printer's tolerance. If you're aware of a different tolerance that works well with your 3D printer, then you can type that out here. We'll also want to make sure the offset sketch geometry is on the inside of the cutout. If it is not, then you can hit the flip button in the dialog box. Then I'll click the OK button in the dialog box to create the geometry. We'll now want to close off our profile shape at the top. I'm going to hit the keyboard shortcut letter T as in Tango to activate the trim tool. Then I'm going to click on the left horizontal line and the right horizontal line to trim them away. This will let me drag each vertical line upwards about 1 millimeter or 2, ensuring that this component will stick out of the track section. Then I'll activate the line tool by selecting it in the toolbar. Next, I'll simply click on the left side and I'll click on the right side to connect them. At this point, you should have an orange background highlight filling the shape, which signifies that this is a closed profile. Before we extrude the shape, we can also add some sketch fillets to its edges. I'll select the sketch drop-down list, then I'll select the sketch fillet command, which is not to be confused with the modeling command that we used earlier. I'm going to click on the bottom 2 points of the profile shape. I'll also go ahead and select the 2 points in the middle of the shape, and finally, I'll select the top 2 corners of the shape. Then I'll type out 1 millimeter for the fillet radius. I'll then hit the Enter key on my keyboard to confirm the sketch fillets. Next, I'll hit the Extrude command in the toolbar, and then I'll select the closed profile that we just created. I'll type out 38 millimeters for the length. Now, if yours is going in the wrong direction, then you can simply add the minus sign in front of the dimension value. Finally, I'll click the OK button to create the slider body. Lastly, we'll want to create a hole on the top of the slider component. I'll select the hole command under the Create drop-down list. Then I'll select the top face of the slider, and you can also click on the top of the view cube to make the model easier to work with. I'll drag the hole until it snaps into the center point. Then we'll change the hole setting so the width is 3 millimeters and the length is 6 millimeters. And then I'll click the OK button. To make this slider even easier to see or to distinguish from the track, I'm going to quickly apply the appearance of yellow. I'll hit the keyboard shortcut letter A as in alpha to activate the appearance command. Then I'll search for yellow, and I'll drag and drop one of the yellow appearance options onto the slider component. At this point, we'll want to copy the slider component to make the second instance of it. I'm actually going to pull this slider component into another Fusion 360 file, and then we'll insert the file back into the main design file. Now this will ensure that we have linked copies of the component, and we only have to update the master copy should we need to make any changes to it. First, I'll right-click on the slider component and I'll select the copy option from the list. I'll then click the New Tab button above the toolbar and I'll quickly save this new file as slider. I'll now right-click and I'll select the Paste New option. Then I'll click the OK button to confirm the paste command. I'll also hit the Save button again to ensure this component is saved. Back in the main design file, I'll right-click on the slider component and I'll select Delete from the list. And I'll confirm that I want to delete the component. Then I'm going to open up my data panel by selecting the data panel icon in the upper left-hand corner. I'll find this slider file and I'll right-click in order to select the Insert into Current Design option, which inserts a linked component into our main design file. Finally, I'll click the OK button to confirm the placement of the linked component. To now create a second instance of this slider, we can copy and paste this linked component. I'll right-click the link slider component, and then I'll select Copy. Then I'll right-click in the canvas window where I can select Paste. I'll type out -51 millimeters for the X distance, as we want this other piece to be in the middle of the track. We also want it to be sliding on the other track, so I'll select the rotate option in the Move/Copy dialog box. Then I'll select the green Y-axis for the axis selector. I'll then type out 90 degrees for the rotation, followed by clicking the OK button. We'll now want to create the arm component that controls the sliders. I'll right-click on the top level component and I'll select New Component. And I'll rename this one Arm. With the Arm component active, I'll select one of the slot commands from the Sketch drop-down list. Under the Slot flyout folder, I'll select the Center to Center Slot option. Then, I'll click at the center point of the circle on the outer slider. I'll drag my mouse cursor to the left. I'll type out 150 millimeters for the distance. I'll click to set the slot distance. And I'll make the width of the arm 14 millimeters. Finally, I'll click to place the slot command. We can now hit the extrude command in the toolbar, and we can select the closed profiles that make up the sketch geometry of the arm. Then I'll make the extrude dimension 4 millimeters for the thickness of the arm. To finish off the arm component, we'll need to cut out a hole for a finger or a pencil that will be used to revolve the arm around, and then we'll also need to create pins that will go into the slider components. I'll hit the keyboard shortcut letter C as in Charlie to activate the center circle command. Then I'll select the top face of the arm component. I'll click on the left side and I'll simply make a circle of 12 millimeters. I'll hit the extrude command in the toolbar. I'll select the circle profile and then I'll change the operation to cut. Then I'll change the extent type to all to ensure it cuts all the way through the arm component. Next, we'll create the two prongs that fit into each hole of the sliders, and then we'll finish off this model by applying joints to it. For now, we'll need to hide the main body of the arm component. I'll toggle open the arm component folder in the Fusion 360 browser. Then I'll toggle open the bodies folder and I'll select its corresponding light bulb. We'll now need to use the offset command to create the tolerance so the prongs will actually fit in each hole. I'll hit the keyboard shortcut letter O as in Oscar to activate the offset tool. Then I'll hit the top face of the slider component, and I'll select the edge of one of the holes. I'll type out -0.4 millimeters for the offset distance, leaving a small tolerance for a 3D printed part. Then I'll repeat these steps for the other hole. I'll stop the sketch and then I'll hit the keyboard shortcut letter O once again. Then I'll hit the top face of the other slider component, and I'll select the edge of the hole. Once again, I'll type out -0.4 millimeters for the offset distance. After each offset is created, I'll hit the keyboard shortcut letter E as in Echo for the extrude command. I'll select both circles to extrude, and then I'll type out a distance of 6 millimeters or the length of each cutout. I'll make sure these cylinders are running into the hole, and you'll also want to make sure to set the operation to join before clicking the OK button. Now, the join operation will ensure that these two prongs join the main body of the arm, resulting in only one body in the Fusion 360 browser. Lastly, I'll hold down the Shift key on my keyboard as I select both the top and bottom faces of the arm. Then, I'm going to hit the keyboard shortcut letter F as in Foxtrot to activate the fillet command. I'll add a fillet radius of 0.5 millimeters and then I'll click the OK button. At this point, we can finish off the model by adding some joints so we can see the model actually function before printing it out. We'll need to use as-built joints because we built our component pieces in place. First, I'll right-click on the track component in the Fusion 360 browser and I'll select Ground. Now the ground option is literally going to ground the component, ensuring that it can't be moved anywhere. I'm doing this to the track as I'm going to add joints to the rest of the components. I'll select the Assemble drop-down list and then I'll select the As-Built Joint option. For the first joint, I'm going to select the outer slider. Then I'll select the Joint Type drop-down. I'll select the Slide option from the list of available options as we want this component to slide back and forth in its track. We also need to select the track component so the joints know where the component should slide. We'll then need to define the position, and because we already have this component in the position we want it to be, I'll just simply click on the center of the end face of the component. Lastly, we can hit the play button to ensure the joint looks correct. Everything looks good, so I'll click the OK button to confirm the results. We'll need to apply this joint to the other slider component as well. I'll right-click and I'll select Repeat As-Built Joint. You'll notice the slider type is already selected as it defaults to the last joint type that you selected. Therefore, we'll need to select the slider that's in the middle this time, and then once again we'll have to select the track. Then I'll select the center of the component for the position. Everything looks correct with the animation, so I'll click the OK button. Next, we need to create revolute joints to attach the pin of the arm to each slider, allowing them to revolve in a circular motion. I'll right-click in order to select the Repeat As-Built Joint option. Then, I'll select Revolute as the joint type. I'll select the arm component and then I'll select the slider component. Then, I'll have to hit the light bulb in the Fusion 360 browser for the arm component, as we'll need to turn this off so we can select the position of the revolute. For the position, I'll zoom in on the hole cutout, and we'll need to select the center point of the cutout. You'll get a warning at this point telling you that the object is not visible, so let's go ahead and turn it back on by selecting the light bulb again. Then we can hit the play button to check the animation. It looks correct, so I'll click the OK button, and we'll have to do the exact same steps for the other pin. I'll right-click in order to select the Repeat As-Built Joint option. I'll select the arm component and then I'll select the slider component. Then I'll have to hit the light bulb in the Fusion 360 browser to hide the arm component once again. And finally, I'll select directly in the center point of the cutout. Lastly, I'll click the OK button to create the joint. At this point, we have the joints to let this Trammel of Archimedes function properly. You can now drag a component around to see it move. However, you may find that dragging the components around is not as smooth as you'd like, and it's hard to make the motion continuous. If I toggle open the Joints folder in the Fusion 360 browser, you can right-click on one of the Revolute joints and select the Animate Model option. This will make the Revolute joints animated, making the model function as expected. Now it's important to note that if you select Animate Model for the slider joints, then the entire animation will not work. To stop the animation, simply hit the Escape key on your keyboard. If you made it to the end of this video, then let me know by commenting below if you're planning on 3D printing this model. If you are going to print this out, then of course you can also tweak the design to better suit your needs. You may even want to add a knob on the end of the arm, making it easier to turn. I designed this one to be simple with the idea that the pins would simply fit into the slider holes. However, you could even create countersunk holes in the arm and add screws running through the arm and into the slider components. You could also make some attachments in order to attach a pen or pencil if you're looking to draw some perfect ellipses. As always, I really appreciate you taking the time to watch this tutorial. If you've enjoyed this tutorial, please click that thumbs up icon and click on that playlist in the lower right hand corner to watch more 3D printing related Fusion 360 tutorials. To be part of the Product Design Online community, be sure to click that red subscribe button and click that little bell icon to be notified of more Fusion 360 tutorials.